Hello, we are looking at the Veggie Soda challenge in web category in Google-CTF 2023 Veggie Soda. This challenge is based off of using a deserialization gadget to deliver an access payload in spite of CSRF protection. Vegetable Soda social media. The application mimics the rough connection hub of people who like vegetable soda. You can send the custom soda as funky messaging mechanism. Make posts that serve as a private notes repository and report suspicious links to administrators. If you attempt to message an admin with your soda or attempt to put a suspicious HTML characters in your post, you will get hit with a warning for committing a violation, accumulating enough violations, and your soda or post making privileges are removed. Admin slash privileged users get a special status function, but standard users don't have the same functionality. These different functionalities interfaces with the database in the backend through classes. The OP design interacts with a queue to manage DB submission and retrieval. All post sodas violations, bios, and statuses are submitted to the queue and processed when the queue is full. The queue will iterate through enough items to be processed and assign it to the user in question. Later, the app pushes a new soda slash bio slash post in the DB, the status page. The status endpoint is completely inaccessible to standard user. Notably, it uses router.all, which ostensibly handles all get, post, put options and delete requests. Route will change a premium user status either by using the request body or request query parameters if present. More specifically, the endpoint gives you control over the type which is used by queue to determine how to process the item. Through the status endpoint, you have control over an item in the queue and how it should be processed. If you can make an admin CSRF a request to this endpoint, then you could inject an item into the queue which can be processed however you'd like. But what kind of request? Application doesn't opt into cores, so only simple requests will be routed. That removes put and delete requests and other pre-flights. So maybe a get or post is the request to make. Despite that, however, the CSRF middleware will likely block you from performing a CSRF attack by vetting all the posts, requests, and vetting all the requests that have query parameters. You will need to determine a way to bypass the CSRF middleware actually to talk to the endpoint in question. A CSRF bypass. There exists a CSRF middleware that is automatically applied to all get and post requests. CSRF protection middleware and gets access edit CSRF if it succeeds, then redirect. If the method is post, you're checking, you're checking. Only if it passes, you go to the next, or else you redirect the slash. With this middleware, a simple request CSRF is impossible, but it can be bypassed. According to the Oak source code, a router is set to handle head requests as get requests with no response body. A common workaround that isn't unique to Oak instead of a specific handler that deals with the head request. There's simply get the get handler, but the app just removes the response body. This code handles the HTTP specs without too much of overhead for the developers to think about making their own head middleware. Even though Oak definitely provides that. To summarize, a head request is therefore treated by the app as a get request. The problem lies with the CSRF middleware and how it checks the method to request. Even though a head request is routed through gate handler, the CSRF middleware won't apply the protection because it it's if check ctx.request.method equal to get returns false as head not equal to get. If therefore the middleware ignores the head request and believes it to be CSRF safe, you can use this to send totally legit GET request that doesn't look like GET request in order to leverage the slash status endpoint des- desired functionality to inject it into the processing queue. The TypeScript deserialization change. Injecting into queue is so important because that kicks off the potential creation of the post that can be viewed by the admin user. The queue will first attempt to deserialize a string, process this class accordingly. The serialization deserialization library is super serial, which follows closely after PHP unserialize API. However, super serial doesn't deal in functions just yet, meaning that deserialization based RC Python pickle isn't possible. Superficial does deal in classes, which is what queue processes. The available classes are these. You can't go to the easy route and inject a rogue soda or a post that easily during processing. All sodas and posts are HTML escape rendering your HTML XML invalid. So you need to find some way to push your soda into the user's array so that it can be inserted into the DB while it's not actually calling sanitized and escaping functions during the process to have valid accesses on the other side. So direct serialization post slash soda wouldn't work, but what about a chain? It's worth nothing that the other classes actually share function names. They perform different things, but they have similar names, and this typically wouldn't be a problem for a type caution language which has generic to asset types, except that all classes in there are generic. So generic constructors can't be used, and therefore the program can't assert types in certain situations when dealing with the serializer. This isn't a problem with the serializer, but rather an oversight in the use of the generics and type assertions in the TypeScript. What this means for us is that we have the possibility of utilizing pub-chain SQ capabilities in TypeScript by leveraging the same named functions to chain together bits of code into a desired result. In this case, desired result is stored accesses. The additional means that queue may consider a deserialized class but processed as specific class even though it's different one. This can usually cause errors. But in this case, we can take advantage of that and leverage it as the beginning gadget to deserialization change. While it is possible to create different chains, the serialization chain that was used in intended solution were as follows. Log class, which has the apply method that subsequently calls e.validate, in which e equal any is a property in the class that we specify to be a bio class which has a validate method that can subsequently call this warning.resolve under an if check where warning is equal to warning is a property of the class can specify that we can specify because type of session to be a soda class which has a resolve method that takes a user argument and pushes itself into the user soda array. This means that the soda will get pushed into the user's object, but it doesn't get sanitized like escape. This last bit that's needed in way to call log.apply, which happens if you serialize string is processed as a post. Through this, you can chain together the bits of code and pop non-escaped accesses into the arbitrary user array. Therefore, all you need now is to have an admin to visit the rogue soda you made and pop the access. Final payload is as so. Script has a URL of status post content converting it into a URL safe string and whatever we thought do and just put URL. So that's it.